Okay, now draw this graph. X-axis, y-axis. Make sure your parabola, let me spell that for you, P-A-R-A-B-O-L-A. Some people play around with it and call it parabola, but it's called parabola. And that's the name of a quadratic, the graph of a quadratic equation. When it looks like a U with open arms, the name of that shape, this shape here that we're looking at, is called parabola. Okay? All right. Now I'm going to help you with the x-intercepts this time. They're actually sitting on the x-axis, correct? So how many roots do you think we have? It looks like we have only one, but that's not true. This is called a double root. That means it's going to be repeated. Good, first period, it's going to be repeated. So if this number is 5, then I'm telling you x equals 5 and x equals 5. You guys want a quick example real quick? You want to see what a double root looks like? Okay.
Yeah.
Let's do, let me put this out there. Let's say x squared minus 6x plus 9. If I did the x factor, it would be 1 times 9, so 9, negative 6 at the bottom. What multiplies to 9 but will also add to negative 6 will some play of 3 and 3. Now, we know 3 plus 3 is 6, but we want negative 6. So how do we get negative 6 with 3's? Make them both negative. Okay, I would divide by the first number, but it's 1, so we stop. Now, I come down here and I do the 0 part. And so I have to add 3. And I get x equals what? And over here I add 3, and what do we get? What do you notice? That's a double root. That's what a double root looks like. Okay? So that would be an example of this. A double root would sit like this on the x-axis. Okay, moving on quickly. Tell me what else you see. The y-intercept. Good job. What else do we see? Minimum. This is a minimum. This is a minimum. Okay, well, what else? The vertex is the double root, huh? It's the same thing on this one. Okay, what else?
Axis of symmetry.
Axis of symmetry. Okay, and axis of symmetry. I'm going to go ahead on the same video, do another graph, because I want to show you one that we won't solve. We won't play around with this one, but you need to know what it means, okay? You ready? New graph, and this time I'm going to draw it upside down, but it's not going to touch the x-axis at all. And I'm just going to go ahead and tell you. I'm not going to even ask you to tell me where the roots are, because you wouldn't know. My first question, does it touch the x-axis, yes or no?
No.
No, it does not. So what does that mean?
There's no.
Good job. I have no x-intercepts for this problem that are real. Remember back on the, what was that, beginning of the year? Remember we did imaginary numbers and the whole hamburger and the irrational numbers and the fries. Remember that? Okay. This graph will give you imaginary roots. So for this graph, because it does not touch the x-axis, the roots are imaginary. And that's all I want to tell you. So the way you would write the answer, if you saw this, because I'm not going to test you over it, but if you saw a graph like this, you would say no real roots. And there are no real roots because they are what? Imaginary. There are no real x-intercepts because they are imaginary. And everything else you still know. Does it have a y-intercept? Yes or no?
Yes.
Yes, it does. It's right here. It still has a vertex. Good job, Alexis. Good job. Okay? What's next? Axis of symmetry. Right down the middle. Ah, good. It has a maximum. Did we leave anything out? No, we're good.